Hello students. So today we are going to do some questions based on inverse trigonometric functions. Okay. So I'm focusing mainly on CBSE questions. Okay. So the most likely questions which are asked in CBSE are based on domain and range. Okay. You have to find certain function is given, then you have to find the domain and range. Then principal value. Okay, then some questions are based on the properties, trigonometric formulas which you have learned in standard 11, so you have to apply them. So we'll find some of the questions we'll solve today. So starting with the question, so please go through the domain and range of the inverse trigonometric functions. Okay, sine inverse is minus 1 to 1, then minus pi by 2 to pi by 2. Okay. And also you should know the domain and range of sine, cos, cosec, sec, tan and cot. Okay. And the properties are also there. Can refer the summary of that trigonometric functions chapter. So these are the properties which you have. Okay. For cos inverse, cot inverse and sec inverse, if the function is negative, if the value which you have taken from the domain is negative, then you have to do this. That is pi minus that value you have to do. Okay. Then these are also the properties. Okay. So let's start solving. So you have to find the domain of sine inverse to x. Now we know the domain of sine inverse of x, that is close bracket minus 1 to 1, correct? So this 2x lies in this interval. So we can write minus 1 less than or equal to 2x is less than or equal to 1. So by dividing by 2, we get minus half less than or equal to x less than or equal to half. So this x belongs to the interval minus half to plus half. Okay. Now you have to find the domain of sine inverse of x plus cos of x. Okay. Now we know the domains of both of these functions. Okay, sine inverse of x domain is minus 1 to 1, and for cos of x domain is whole of r, right? So whenever plus is given, so both domains are included, so you have to use intersection. Okay. So here it is given that sine inverse 1 minus x square plus cos inverse 1 minus x square is equal to pi by 2. We have a property, right? Sine inverse of x plus cos inverse of x is equal to pi by 2. Okay. So, and we know that sine inverse and cos inverse have a domain minus 1 to 1, right? So this 1 minus x square falls in the minus 1 to 1. So we can write falls in 1 minus x square is 1 to 1. So we have to find the range of x. This is not that range, okay? That is domain and range kind of thing. You have to find in which interval the x belongs, okay? So we have to find x. So we can remove this 1 by adding 1, subtracting 1. Okay. So this is minus 2 minus x square 0. Then you have to remove this negative sign. Whenever we multiply by a negative sign to an inequality, the inequality changes. Okay? So it becomes greater than or equal to. Okay? So this is x square is given. When you take the root, okay, then you will get two values plus or minus 2. So this 0 is also included. So this falls in between minus root 2 and plus root 2. Okay, in between there is 0 also. So the x belongs to minus root 2 to plus root 2. Okay. Next question, you have to find the domain of cos inverse x square minus 4. So again, this x square minus 4 falls between minus 1 to 1 because domain of cos inverse is minus 1 and 1. Square minus 4. Okay. So removing 4, you will get so this x square falls between 3 and 5. When you take the root, this will be root 3, this will be root 5. So this is plus or minus root 3, this is plus or minus root 5. Okay. So you will get two values, that is minus root 3 plus root 3 minus root 5 and plus root 5. So you will get two intervals, that is your x will belong to one interval will be a set of negative numbers, that is minus root 3 to minus root 5, right? And another interval will be root 3 to root 5. Okay, union. This is minus root 5, which is a smaller number. Okay, let's solve this. So here the function is defined as y is equal to f of x. Okay, and this equation is given. You have to find the range of x. That is, you have to find the intervals in which this x belongs. Okay, so solving this, you'll get x square minus cos inverse y is equal to pi. So minus cos inverse of y is equal to pi minus x square. So this is cos inverse y is equal to x square minus pi. Now, if you want to find in which this interval x belongs to, you have to go for the range of y. Okay, range of this cos inverse. So, range of cos inverse is 0 to pi, correct? Cos inverse 0 to pi, close bracket. So, this value falls between 0 to pi. Okay, removing pi here, we'll get adding, we are adding pi. So this is 2 pi, right? So again x square is there. So you'll get here two values, plus or minus root pi and plus or minus root 2 pi. Okay. So the first interval will be x belongs to minus root 2 pi to minus root pi union root pi to root 2 pi. Okay. So this is the range of x. So you have to find value of this. Okay. So we can take, let's say, sine inverse of x at some theta. Okay. So your sine theta is x. Okay. This is nothing but x by 1. Okay. When you draw the triangle, suppose this is your theta, sine theta is opposite upon hypotenuse. Okay. So what will be the value of adjacent? Using Pythagoras theorem, we will get root of 1 minus x square. Correct? So we have to find cot sin inverse of x. Sin inverse of x we have taken theta. So cot of theta we want. What is cot of theta from here? Cot of theta is adjacent upon opposite. Okay, whenever this kind of questions are given, try to draw the triangle and see how to find the value. Okay, this triangle method is very easy. Okay, you have to find value of cos inverse cos 3 pi by 2. Now this we can't write it directly as 3 pi by 2 because this 3 pi by 2 does not belong to the range of cos inverse. Okay, which is your 0 to pi. So this 3 pi by 2 does not belongs to 0 to pi. So you have to find the value of cos of 3 pi by 2 first. So cos of 3 pi by 2, 3 pi by 2 is nothing but your 270, right? 270 is opposite of 90. What is cos of 90? Cos 90 is 0, correct? So cos of 3 pi by 2 is also 0. So this is 0. Cos inverse 0 is pi by 2. Okay. So always look for the range. Directly you can't write the value. Let's solve this. So here you will need help of some trigonometric formula. Okay. Now if I take this as x, this as y, okay, and this here I'll write 33 by 65 and cos inverse I'll take this side, so this will be cos of x plus y, correct? So you can use the formula cos x plus y, which is cos x cos y minus sin x sin y. Okay, that we have to prove equal to 33 by 65. So I'm taking the left hand side and then I'll go to the right hand side. Okay, so I've taken cos inverse 4 by 5 as x. So what is the value of cos of x? 4 by 5, right? Constructing the triangle, you'll get adjacent upon opposite. So this. Okay. Now take value cos inverse 12 by 13. So cos y is 12 by 13. Okay. Again constructing the triangle with y as angle, you will get 12, 13 and this is nothing but 5. Okay. So now you have, from this you can write the value of sin x. Sin x is 3 upon 5. And what about sin y? 5 upon 13. Okay. This values you have to substitute in this. So cos x plus y is cos x cos y minus sin x sin y. Okay. Now we are taking LHS. So cos x is 4 upon 5. Cos y is 12 upon 13. Sin x is 3 upon 5. And this is 5 upon 13. Okay. So remain the denominator we are keeping as it is. This is 65 and this is 48 minus 15. So this is nothing but 33 by 65, which is our RHS. Okay, there is another method to solve this also, that is by using the trigonometric identities. Sin square x plus cos square y equal to 1. Okay, that also you can use, or you can go for the triangle method. Okay. Next question, you have to find tan of half cos inverse root 3 by 5. So again you have to take this cos inverse root 5 by 3 as some theta. Okay. So this will be cos theta equal to root 5 by 3. Okay. Now the equation becomes, this equation becomes tan of, this is theta, right? And this is half is there. So theta by 2. That is half angle. Tan of theta by 2. Now we have to write this cos theta in terms of some half angle. Tan theta by 2 we can write sin theta by 2 upon cos theta by 2. Okay. So this is cos theta we can write in terms of sin theta by 2, and this half angle formulas, that is if you have cos 2x, that we can write 1 minus 2 sin square x, right? And same way cos 2x you can write 2 cos square x minus 1. So when you take the half angle, this becomes sin x by 2, this is cos x by 2. So you will have the formula, if you take upon, then you will have tan theta by 2 as root of 1 minus cos of theta upon 1 minus 1 plus cos of theta. Okay, you can write it by using this formula. So substituting value of cos theta, you will get 1 minus root 5 by 3 upon root of 1 plus root 5 by 3. Okay. So this is, when you take this here, cross multiply. So you'll get 3 minus root 5 upon 3 plus root 5. Denominator gets cancelled. Okay. So this is tan theta by 2. So find the value of x. Okay. So you have to simplify this. You have to, this is tan inverse, this is also tan inverse, right? So can we make it both tan inverse, because here 2 is there. So we can write this as 2 tan inverse of some x, and our x is cos of x. Okay. So using the formula, that is tan inverse of 2 tan inverse of x, you'll get tan inverse 2x, that is 2 cos x upon 1 minus x square, that is cos square x. Okay. Here you can use the formula of 2 tan of x also. Okay. Then here it is tan inverse 2 cosec of x, that we have to keep as it is. A cosec of x you can convert into sine. Okay. So now this is tan inverse, this is also tan inverse. So we'll get 2 cos of x upon 1 minus cos square x equal to 2 upon sine of x. 1 minus cos square x, we can write it as sine square x. Okay. This 2 gets cancelled. Sine square x, one of the sine square x gets cancelled. You will get cos of x upon sine of x equal to 1. Okay. So this is nothing but cot of x equal to 1. So the value of theta, that is value of x, and cot of x is equal to 1, is nothing but pi by 4. Okay. Okay, so here it is given that sine inverse of x minus cos inverse of x is pi by 6. You have to find the value of x. Okay. We have the property, that we know the property that sine inverse of x plus cos inverse of x is equal to pi by 2. Correct. So if you take this as equation 1 and this as equation 2, so if you add these two equations, okay, then this cos inverse minus and this plus will get cancelled, right? We'll get 2 sine inverse of x equal to pi by 6 plus pi by 2. Okay. So we'll get this as 3 pi plus pi, 4 pi upon 6, which is 2 pi by 3. Okay. So taking that to that side, you will get 2 pi upon 3 into 2, so pi by 3. So sine inverse of x is pi by 3. So x is sine of pi by 3. Okay. This is nothing but 60. Sine of 60 is what? Root 3 by 10. So this is the value of x. Okay. Let's solve this. So we have to prove this left hand side equal to right hand side. So starting with left hand side. Okay. So I'll take sine inverse 1 upon pi root 2 at some x. Okay. So sine of x is 1 upon 5 root 2. So using the triangle method, we'll get 1, 5 root 2. So 5 root 2 square. So this is 25 into 2, 50 minus 1. So this is 49. Right. So root 49 is 7. Now wait a minute. 5 square 25 into 2 minus 1 square you have to do. Right. So this is 50 minus 1, which is 49. Okay. So it's root 7, correct? Okay. So we have to find cos of 2 into sine inverse of 1 upon 5 root 2. Now this is sine inverse of 1 upon 5 root 2 we have taken as x. So this is 2x, cos of 2x. This we have to find. Now cos 2x we can use the formula 1 minus 2 sine square x. Okay. So this is 1 minus 2 sine square. Sine is this 1 upon 5 root 2 square. Okay. So this is nothing but 1 minus 2 into 1 upon 25 into 2. So 25 minus 1, which is 24 upon 25. So we got the value of this. Okay. Actually no need to construct the triangle because we don't need any other value. We only needed the sine of x value, correct? So this is 24 by 25. Okay, so we got the LHS as 24 by 25. Now we have to find RHS. So again you have to take cos inverse 3 upon root 10 as some x. Okay, I'll take it as y. So cos y is 3 upon root 10. Okay. Now we have to find the value of sine 4 cos y. This is y. Okay. Sine of 4y you have to find. Okay. So here we will need sine of y. Okay, because we are going to use sine to theta formula, which is 2 sine theta into cos theta, and we need sine for y. So we have to double this angle. So sine for theta will be 2 sine 2 theta into cos 2 theta. Okay. Further, we have to reduce this sine to theta and cos to theta. Okay. That is sine to theta can be written as sine theta into cos theta, and cos to theta can be written as 1 minus 2 sine square theta. Okay. So I'll write here sine 4y. Sine 4y can be written as 2 sine y into cos y into 1 minus 2 sine square y. Okay. Now we have to substitute the value of sine y cos y. So cos y we have 3 upon root 10. So using the triangle method, this is y 3. So this will be 3 square 9 minus 10, which is um, this is 3. This is root 10. Okay. So 10 minus 9 1. So this is 1. Okay. So sine y is 1 by 3. So substitute the value 1 upon 3 cos y 3 upon root 10 into 1 minus 2 sine square y 1 upon 9. Okay. So we'll get 2 upon root 10 into 9 minus, oh sorry, this is 1 upon root 10. Okay. So this is 6 upon 10 into root 10 minus 2 upon root 10. Square this, you have to square, right? So it will be 10 minus 2 upon 10. So 6 into 8, 10. So this is something we have missed. Okay, I'll write it once again. Okay, so the mistake was here, that is here one more 2 was there which I had not written. Okay, now we'll get the answer, that is this is 2 to the 4, 4 3 is 12 upon 10 into this is 10 minus 2, 8 by 10. Okay, so 24 by 25. So this is LHS equal to RHS.